Welcome everybody to FOP day 14. I want to say 14. We are in our last week. I think it was day 15 actually. We are in our last week of foundation of programming. Thank you guys for attending. I hope for those that were not here last week, you guys were able to review the video of reading and writing files. We're going to start off today by reviewing the assignment that was assigned to you guys before we went on the weekend. Because chances are you guys probably didn't do it, which is okay. But that way we can kind of just talk through it, and then for those of you that might not have been here, yes, last week we kind of get to see it firsthand and how we're gonna do that. So uh, I am almost done getting ready. Give me a second. I just had to pull out my notes because this is a big assignment. Okay. All right. So let me go and share my screen. We're gonna jump straight into it. I'm sure you guys are ready to put some code onto uh your screen. Do you guys see my SAT data empty or no? Okay, good. All right, I want to make sure I was sharing the right one. All right, so last week we finished the day. We not had too much time to talk about the SAT one. This is a pretty heavy one. But essentially, we had to create a class, right? Using as well the JSON module. So we had to create a class called SAT data that was supposed to read this SAT.json file, right? Uh, and we had to write that data to a text file in CSV format. Essentially, the file that we're being given is this file right here, which is a JSON object, right? Um, and it is the data of a school. Um, in the README, I guess it's not here. Oh, okay. In the folder, you should have the CSV file as well. Um, and the CSV file looks something like this, right? We have a CSV, which stands for comma separated value. And it's called comma separated values because we see here that we have different types of columns and rows. At the very top, we have our first line, which consists of the headers. Typically, CSV files, their first line is the headers, which is supposed to let you guys know as the readers or developers what the data is supposed to be within this file. Line one, we see here we have DBN, which I believe, if I recall, is called district borough numbers. Then the school name, followed by the number of test takers, and then we have the means for critical reading, mathematics, and writing, right? For the scores for each school. So this is the data, the total data, all right? And then we also have our JSON here. Now, how do these come into play? So essentially, this class is supposed to take in the JSON file, this right here, uh, and then it's supposed to write the data to a text file in CSV format. That text file needs to look something like this, right? We have to grab this data and convert it into a CSV file that looks like this. And they gave us the example, right? CSV is a very simple format, just commas separating columns and new lines separating rows. Your class should have an init method that reads that file and stores it in a whatever data member you prefer. Any data member of the SAT class must be private. So just like always, we're going to go ahead and just start defining our class. As you recall from line one of the agreement, we have to import JSON because we are working with a JSON object. So we're going to go import JSON. And then we're going to define our class called SAT data. So the very first part of our class, like always, is going to be our init method. Going to take in self. And now for the arguments, it doesn't say anything about arguments, right? It says that it should be able to read the file and store it whatever data members we prefer, but Nothing about taking any kind of arguments, right? So it should just be self, you know, and it's not a customizable. It should just take in by default, be able to instantiate this class and immediately just read a file, right? So yeah, it just reads file. So we don't need to pass anything in here. We could if you want, if you want to make it customizable, but no actual reason to it. So reading and writing files. So if you guys recall from last week's lesson to read and write, we're going to start this by using the with open command. And then the with open command is going to take two different arguments. The first one is going to be the name of the file that we want to read. Ours is going to be that sat.json file that we have within the same directory. So we're just going to go ahead and type in the name of the file, sat.json. And then the second argument it takes is going to be what we want to do with this file. Well, we're only going to read the file. We only want to be able to grab access to it. We don't need to write anything into this file. So the letter we're going to add in here is going to be R, so we can read the file. So after the file is open, we have to give it an alias that we can save it to, almost like assigning a variable. So we're just going to say this as in file. Why am I calling it in file? That's just kind of like the naming conventions that we use here, because I'm grabbing a file and I'm grabbing information from it. I'm bringing it in. Whereas when we're writing into a file, we call that out file. So we're going to write out into that file, if that makes sense. So we're just going to give it alias of in file. And now we want to grab all this data so we can kind of start manipulating through it. So I'm going to declare a variable here called all data. And I'm going to load it in, right? So recalling from last week's class, let me just actually open up our class schedule and show you that as well, so we can see where we're getting this information from. So if you go to the read and write files, there is a method that we use, which is json.load for JSON objects. So, right. So importing information using JSON. So we have the json.dump and the json.load. Because this is a JSON object and we want to bring in information, we're going to use the json.load method, right? So within here, to get all the data, we're going to say json.load. And what do we want to load into this variable? Well, we want to load the entire document. So we're just going to say in file. I want to load in file, right? Now, to test out our methods, I know you guys like to ask, like, how would I test this out if I want to print stuff? Let's just leave it at this. Let's go ahead and see what this is doing, right? So I can kind of finish off that init method there. Let me create this SAT data. I'll just call it SD is equal to. I'll instantiate this class. It doesn't take any kind of argument. And then when I do this, it should automatically initialize it and print this out for me. So I don't have to do anything crazy here. Let's just come back down here and run this file. This is lesson 10. We are in SAT data and let's do Python SAT data.py. Okay. So I went ahead, I ran that file. When this file is ran, it imports JSON, it reads through my class, and then it instantiates that class. Well, because there's no specific method that's doing this, the moment it is initialized, this method is ran, right? The init method. Therefore, it's printing something out for me. And we see in my console, it's printing out the data that's located within the JSON document. Obviously, I'm not going to use this to kind of parse through it because this is a little unreadable. It's not very organized. Whereas we have the file itself here that we can kind of go through it. But this is how you would kind of debug your stuff to see, like, is everything working so far? Am I able to grab the data? I'm not too familiar with reading and writing files. Let me see if what I'm even doing is actually doing something for me. So I got that. Let's go ahead and clear this terminal because it bugs me. Now, going back to the README. So we're supposed to take in all the information, right? And what are we supposed to do? We have to format it and write that data to a text file in CSV format. Okay. Well, we have to grab the information from here and essentially make it look like that CSV file, right? We're looking at the CSV file that was given to us. I need to be able to create a couple headers, right? I need to be able to create the DBN school name, number of test takers. I can essentially pre-format this myself. But we also need to be able to find it, right? So uh let's go ahead and do that. Let's look at our README. So that name method is supposed to take in all the data and save it to a private data member. Okay. Well, I was able to create it. And we have it here on all data, right? So let's just save it in there actually. I can say self dot underscore all data is equal to all data. All right, it saves that information. Next, the method that we actually have to create as well is going to be save as CSV. That takes as a parameter a list of the DBNs, district burial numbers, and saves a CSV file that looks like the SAT college board. Okay, so now we're actually getting to main meat and potatoes. So let's go ahead and create that method. Define save as CSV. It's supposed to take in a list of DBNs. So let's just declare that variable list of DBNs. All right, that's what's going to have to be passed in here. DBN. And save the CSV file that looks like the SAT college board. So essentially this method needs to be able to go into my all data and then format my work and put it in a CSV file, right? I need to create that CSV file. I don't have it. And you guys recall from last week's class, when using reading or writing for the with open method, reading, if I try to read a file that does not exist, it gives me an error, right? But whenever I use the W to write into a file that does not exist, even though the file does not exist, it'll create it for me. So I need to be able to create a CSV file using the with open. Is there a specific name for this file that needs to be called? No, we just call it dbn.csv. All right, this is going to be our CSV file that we are creating. We're going to write into it. And then we're going to say as out file, right? Because this file is, we're going to write into it, right? Our data is going out into this file. And then we should be able to do out file dot write. Now, what are we going to write into it? Well, I know it has to match this. It has to have our header, and then it has to have the information. So I can take it one step at a time. First and foremost, the first thing I'm going to write here, I'm going to run on line 13, my first command, which is going to write the header. So I can go ahead and just manually write that in. It's not a lot. So why not just manually type it in? It should look like this. The first row that's going to write is going to be DBN school name. As a matter of fact, let me just copy and paste this because I'm an impatient man. And there you go. All right, our header should look like this. It should be DBN school name, number of test takers. There's no spaces here. I don't think it's gonna need space. We'll just keep it like this for now. All right. So I'm gonna run outfile.write. It will write this first line into my new CSV file. And then after this line is written, the next line of code should be able to write in the next rows in the same manner that my header is dictating. It should be DBN, school name, number of test takers, so on and so forth. Right? Well, let's format that data. Now we can format it in two different places. We can format this data, right? We can parse through the SAT.json file we have. We can do it here and save as CSV, or we can do it whenever we initialize it and grab all that data. If you look at this data, a lot of this data isn't really needed, right? We have stuff like IDs, name, asset type, attribution, provenance, all this stuff. A lot of this is not really needed. What do I really need? I need to be able to grab this information, DBN, school name, number of test takers. And the only reason I know specifically, all this is because, I already looked through it. But let's say I haven't seen this yet. Let's parse through this SAT data, right? Let's start from the very top. It's an object, right? What is the first key we have here? We have meta, right? Meta is the first key here with a value being another object. Well, let's see where meta ends, right? It's still line 2, and as we hover down, it keeps scrolling down. Where does meta end? Right? It keeps nesting inwards. Meta has a value which is an object. The first key inside meta's value is view, and that has another object which has columns, and it keeps going down. And we see here none of this really matter. Just kind of looking through it as I go down. Oh, here's something that matters. DBN. DBN is one that matters. DBN. We see item counts. We see a bunch of different items. We keep scrolling down. Next, I have name. I have school name right here. School name pops up as the next one. And then I can kind of start depicting this or kind of identifying what this is. We see here the value was called columns, and it was a list, right? The value is supposed to be a list. Or what is each item within this list? The first one is SID. Next one is ID. Next one's position. Next one's created at. Next one's created meta. Next one is updated at. I can see the name of whatever these objects are. Meta DBN, right? DBN, that stood out, right? DBN is the next one. Next, we see school name. Okay, so I can see this is kind of giving me columns, and then each column has different data that goes into it that's respective to the name of that column. This column is for school name. This column is for number of test takers, right? Critical reading mean. So it looks like I have to go into meta. After I get meta, I need to go into view. After view, I need to go into columns, and then within columns, I need to grab the information in there, right? All right. So how do we do that? I want to be able to grab everything within here. Let's start parsing through it. We have self.all data. Before we even load everything in here, let's get information here. Print all data. What was it giving me? All right, we saw that meta was the first one. So maybe go into meta. Let's finish going down. So that told me what the columns were. Okay, here we have another one. This is what I get for not going all the way through it. After meta ended, we get another variable or another key. We get data. So meta was the first key, and then it goes to data at line 848, it looks like. That's the second key in here. Look at what the value is for this key. We see right here what looks like a DBN. We see what looks like a school name, and then we see some numbers. The next item within this list, same concept. We see a DBN, a school name, and some numbers. We see 4 different numbers. Well, let's look at what the CSV looked like. It was supposed to take in a DBN first, and then a school name, and then we have 4 different numbers. We have number of test takers, critical reading, mathematics, and then writing mean. Right, that looks to be like the pattern of how it should be when it comes to the information for the DBN, right? Let's go back to it. We have the DBN, the school name. This might be number of test takers, and then the critical reading mean, so on and so forth. It looks like each item within this list represents a DBN as well as their school and their statistics. If we go back to meta and look at columns, that might be what it is telling us to do. It's telling us how the format is supposed to be. School name. What happened after school name? After school name was number of test takers, right? That's one of the numbers that we got back. After school name was critical reading mean. That's supposed to be a number value. Mathematics means another number value. And then we have writing mean. That's a number value. After that, it goes into other random stuff that I don't know what it is. But it's no longer columns. Notice how this goes to columns. After it talked about the writing mean, that was the last column it showed me within this list. and it goes into another key value, which is grants. Grants seems irrelevant. Metadata seems irrelevant. Owner, that's other stuff that's relevant. So it looks like the column was telling me how this is broken up. And then after meta key value is done, it goes into the data key, and then we get a list of lists. And it looks like this, right? But it looks like I only want what's after 1, 2, 0, 1, 2, 3, 4, 5, 6, 7, 8. Right? So I want to be able to go into the data and grab this list of lists. So let's go ahead and do print all data. And then what key was it that we were trying to grab? Let's try to grab the data key. All right, we're gonna grab the data key. Let's clear this out and run this again. Okay. We get significantly less stuff. And notice from the very top, we are now getting a list of lists. The first list within this item right here is an index 0. It runs all the way to here. We see DBN within it. We see the school name. We see 4 different numbers. So test takers, critical reading mean, mathematics mean, writing mean. So it looks like I'm grabbing a list of lists. So I want to loop through this list so I can grab every individual one. And after I grab each list within this list, I only want to grab specific indexes. I want to grab this index to the very last index. What is this? 0, 1, 2, 3, 4, 5, 6, 7, 8. Right. Okay. I want to grab everything from index 8 to the end of that list. Right. That'll grab me the DBN, school name, and all 4 numbers for each different school. And that's all the data I really need. I don't need all that extra stuff within this JSON file because I'm just trying to grab this. I'm trying to grab this information. Right. So let's do that. Right. Let's go ahead and create a new variable called formatted data. There's a formatted SAT data. Right. And this is going to equal an empty dictionary. For this empty dictionary, I'm going to save the key I'm going to give it is going to be the DBN. Right. Why? Well, the method that we have to create should be able to take in a list of DBNs and then grab the respective data that belongs to that DBN and save it into a CSV file. So maybe it would make sense that when I create my dictionary, I'm able to access the different schools by their DBNs, right? So I'm gonna add a little note here. The key is going to equal to DBN, right? And then the value, I want it to equal to list of DBN data, right? That's how I will remember it. That should be everything that goes between the DBN, school name, and then number of test takers, as well as their 3 means. That's what I want the value to be, which essentially should be another list, right? All right, so let's actually get into some formatting here. How are we going to do this? Well, I know that all data, and then using the data bracket, returns to me a list of lists, right? So first and foremost, the only way to grab every single item within the list is to start a for loop. I'm gonna have I have to manually go through every single one of these by doing a for loop. Sometimes there's no other way. Like the data we have here is stored within a list. There is no other better way to grab this, even though it would be better, especially depending on how much information there is here, to be able to grab all the information in a much faster and more efficient way. There is none. So I'm going to have to do for DBN list in, and then let's start the for loop within this list of lists, right? And let's see what that looks like. Let's print out DBN list. I already misspelled it. Let's print out DBN list. If I'm losing you guys, I need you guys to stop me and let me know, right? Do not let me continue being lost in the sauce, all right? So let's see what that looks like. Let's clear up our console. Let me lower a little bit so you guys can kind of see the code. Let's clear the console and let's run this. There we go. A little bit more formatted now, guys. We got something a little bit better. Let's look at this. We see as I'm looping through the list of lists, I print out every single list within this list. I know listception. Don't get too confused, all right? And we see here each list has, index 0. It's some random hash that doesn't really matter to me. Random numbers doesn't matter to me. None of this matters until we get to index 8, right? And index 8 is the DBNs. After index 8, index 9 gives me the school name. Index 10 gives me the number of test takers. And then the rest of indexes give me the means, right? I want everything after this, guys. And I want to save that into my formatted SAT data, right? So as I'm going through here, what I should be doing is I should be doing formatted SAT data, and I'm going to create a new key. What should that key be? It should be whatever is in index 8 of the DBN list. So it should be DBN list index 8, right? That is going to save the DBN as a key into this dictionary. And then after I say the key, what should the value be? It needs to be the rest of that information, right? Well, how are we going to add all the information? We eventually have to format it, right? We're going to have to format it for it to look just like this. Where we do the formatting doesn't really matter. It's wherever you want to do it. If I'm already looping through all this information and grabbing it, why not just format it now and save it into my value instead of doing another for loop later on and having to format it again somewhere else? It's just going to make more work for my computer. So I can just format it here. I'm already going through this for loop. Why not? It's not really going to
zoom in 2 clicks when you get a chance.
zoom in. Does it help?
Yep, that's good.
So I can format it later, or I can format it now. Well, I'm gonna format it now. I'm already looping through this data. Why not format it now, right? So what I'm going to do is I'm going to join the DBN and all its information in this exact same manner. I want to be able to save the value to be exactly what this is. That way, whenever I use my save as CSV method with a list of DBNs, all I have to do is be able to grab the value using the DBN, and it's going to return to me already pre-formatted information, right? So essentially, what I'm going to do, because there are different values, right, within this list, I need to grab every single value and then join them together in some form of string. Well, Python has a method. I don't know if you guys have used it yet. It's called dot join. Are you guys familiar with that method? Right, the dot join allows you to join different things together with some form of separator, right? And we can declare that separator, and I'm gonna declare that separator to be a comma and a space, right? So I'm gonna grab all these different things and I'm going to join them together with a comma and a space. That way it replicates how this should look like. As a matter of fact, I don't even think I need the space. I'm gonna take all that space. It's just be a comma. I'm gonna say opening, close, parentheses, or quotation marks. I'm gonna do a comma, and I'm gonna use a dot join method. Now, what do I want to join? Within the dot join method is what I put in here, what I want to join. Well, I have to join row 8, or not row, it should be DBN list index 8. DBN list index 8. So I want to grab the first item that's going to be joined in here. It's going to be the DBN list. I'm going to do it in the order that this CSV file is telling me that it wants it, right? So it should be index 8, and then it should be index 9, and so on and so forth, right? I'm going to join all these values together with that comma. So you guys do the same thing too, because it's going to take me a little bit to kind of code it together. How many rows are there or indexes? 13? It's 8, 9, 10, 11, 12, 13, 13. Okay. So 13 different values that need to be joined together with a comma. All right. There we go. So you can't see it, right? Because it's all on this line. But essentially, I'm joining everything together using a comma. What am I joining? Everything within this dot join method. So this should be saved within this dictionary as a value. What's the key that's being assigned to it? Its respective DBN number, right? And now let's see what that does for me. Let's print out that formatted SAT data. Let's print formatted SAT data, and then I want to grab whatever DBN list is in here. Let's run it. Let's see if this works. Okay. String.join takes exactly one argument, but 6 were given. Okay, I see why. So it's saying that these are way too many, right? It should take only one argument. Well, I can join them together by putting them all within a list. Right? It's gonna take this list and it's gonna combine everything within the list. Let's run it again. It says sequence type, sequence item number 2, expected string. I got none type. What's going on here, guys? Who can guess what's going on here? Why did I get a none type error? Because the dot join joins together strings, right? Or numbers that are strings. But I'm getting a none type somewhere. Why am I getting a none type? Who can guess?
So there's none in the data.
Because there's none in the data. Let's look at the CSV file, guys. Here we see an example of one. This one has no values. One of these values has no test takers and no means. And that's not the only one. We have another one here, another one here, another one here. There's multiple of these that are going to return nothing to me. Well, how can I fix that? Well, there's a way of doing it. It's a little out of scope, but hopefully you guys can keep up. Have you guys ever seen that clip from The Office where I forgot what guy, he's supposed to be like a dumb character in the show, where he's just like he's not saying a lot of words, so he's like, why say many words when small words is the same? Right? He's like doing this whole bit where he's like, instead of saying a full sentence, he cuts out parts of the sentence and he just says the important parts of it, but it still gets the meaning part, like gets the meaning through. We're gonna do something very similar to that, right? Where we're gonna do like an if-else statement. And it's gonna look something like this, right? We're gonna start with with index 10. Why index 10? Well, that's because that's the first number that we're gonna be encountering that might come back as 0, right? And we kind of see that pattern here. Everything has up to a school name except actual values for test takers. So on index 10, we need to add some kind of functionality that is either going to return an empty string, just like this shows to us, or return to us the value of index 10 if it exists, right? And it's going to look something like this. We're going to put opening close parentheses. And then within here, we're going to say opening close quotation marks, right? This is going to mean an empty string. I want to say opening close quotation marks if whatever is in DBN list index 10 is equal to none. Right? So give me an empty string if DBN index 10 is equal to none. Right? Else, give me DBN list index 10. right? It's an if-else statement essentially here. Once again, I'm gonna repeat the logic behind here. I want you to return to me an empty string if whatever is in index 10 of DBN list is equal to none. If not, I want you just to give me what is actually in index 10. Does that make sense for you guys? We're doing an inline if-else statement, right? So when it runs this, when it gets to that specific part of the dot join, it's gonna check what value should I be adding here? What should I be joined together? Well, it's gonna check whatever is a DBN list index 10, and we've added the functionality that if we get another none type error like we did here in my console, then I want to return an empty string. If not, then I want you to return to me what's actually in there. Because that if it's not empty, if it's not a none type, that means it's a number. And I need that number. Right? That's the first one we're gonna do it. Now we have to repeat the exact same functionality for everything following. Why? Well, because that was for the number of test takers, but we see here for the 3 means, it's doing the exact same thing, guys. Doing the exact same thing. So that means that we need to do the exact same thing for this. For list 11. So it's gonna take me a little bit, but I'm gonna go ahead right in. So empty string if DBN list is equal to none, else DBN list index 11, right? All I'm doing is repeating the exact same functionality that I did on index 10 for the other indexes. I know it's a little lengthy here. I'm just pre-formatting now, so I save some headaches later. There's different ways you guys can pre-format this if you want. This is just my method of doing it. You guys are welcome to try other stuff out. Once again, for DBN list 12, empty string if DBN list 12 is equal to none, else DBN list index 12. And then last one, empty string if DBN list index 13 is equal to none, else DBN list index 13. Why is this giving error? Wait here. Oh, there we go. DBN. Okay. All right, let's try that out, guys. This should work. We might get an error only for one other reason, and I'll talk about that in a bit. There is an issue here somewhere. I forgot a bracket, I think. Where did my error go wrong? Okay. Am I missing? What am I missing? I think I'm missing. There we go. Sorry, I accidentally deleted a bracket. Okay. Now let's try it out again. I'm getting expected string instance none type. Okay. That was my next issue here. I'm getting a string issue here. So what's gonna happen is I have to wrap the row 10 within a string because it's returning either none or a number. So I'm gonna have to wrap these around the str method. str str str, right? Somewhere along this line, it's expecting a string, but it's not getting a string. So this needs to be wrapped around a string wrapper. So when it returns to us, it can read it. And let's try that out now. This should be the last one. All right. There we go. Perfect. Now we see the formatted data, guys. We see our DBNs, the name of the high school, and then we see the 4 numbers finally being printed out, right? We see here that if it's empty, it's returning empty string. So there's nothing within these commas, right? And they're successfully being printed out as strings, no longer as integers. Right? That took a little longer to format them, but now I was able to format all the DBNs here. Literally all the DBNs. Look at that. All this information here, all pre-formatted in the exact same manner that my CSV needs to be formatted. So like I told you, you guys can do this anywhere you want. You can either do it in the init method, you can do it within the save as CSV method. It don't matter. Eventually, you're gonna have to format it somewhere. How you format it can be up to you. If you want to manually read through every single time to find each one, you can go through your own headache. This is my way of doing it. I'm already looping through it, so why not just pre-format it all on one line? Sure, it might not be sexy, right? It might not be sexy. Well, you can add a note here, right? Add a note here where it says line 11 formats in this, or you say line 11 format, and you can give this where it says like DBN, school name, right? Kind of just give some explanation of what's being formatted in here, right? So they know. But yeah, so that is a little labor intensive, but we got it working. So now that gets saved in here as a value. And what was a key? Well, we saw that it was the DBN number itself. So formatted SAT data is good to go. We should be able to actually save that formatted SAT data. We're gonna save it to the all data member we created, because that's honestly what really matters. We don't need all that other garbage. We already have a formatted SAT data that we needed. All right, let's go ahead and get rid of these print statements. No longer needed. Let's clear it up. Now, our data is formatted. We have the headers written in here. Let's move forward, right? So we wrote the headers. The next part was to grab that DBN list that's being passed in here as an argument. I want to use this list of DBNs, and from this list, I need to be able to go into the formatted SAT data dictionary and find the DBNs that are being requested of me. So I'm going to loop through this list for DBN and list of DBN, right? This is the list being passed in as an argument. I'm going to grab that DBN and I'm going to say if DBN is in self dot underscore all data, I'm checking my data member here. That data member is what's holding that dictionary that we just finished formatting. If it exists in there, then I need to write it into my CSV file. So I'm gonna say out file dot write. And what am I writing? I am writing the data for that. Remember, how did we save it? How do we save it? Well, we assign the key of being the DBN, so we're gonna call it by the DBN. And then after we write it into our file, what do we need afterwards? Because it's a, it's a CSV, we need to start a new line. So we're gonna do a plus /n. That way it starts a new line. And then afterwards, we should be able to just return. Okay, cool. That is good, right? That should be good. Actually, I don't even, no, I don't really need to return. Anyways, that's done, guys. Let's go ahead and try out that method. So we have the SAT data here being created. The moment we instantiate, it's gonna run that init method and pre-format our entire SAT.json object into our all data member. And then to actually create that save as CSV, we have to call that method. So I'm gonna say sd.save as CSV, and then I'm gonna pass in a list of DBNs. I believe the README has an example. Here we go. We're gonna pass in this list of DBNs. Would you say DBNs equals that? And then pass in DBNs. And now let's run this, guys. I run it. Notice on my left side here, on my files, we have a new CSV file that just populated, guys. It has the EU for untracked. We just got it, just brand new. Let's click it. We can see it. And now we see the fruits of our labor, guys. We see the first line that we wrote. It's the headers. And it looks like we added some actual extra stuff too. Where did that come from? Let's go back. What the heck did I add? That's weird. Critical reading mean, mathematics. Why is it adding? It's adding some extra stuff. I don't know where that came from. We'll check it out in a bit. But we passed in a list of DBNs. Oh, I see what's happening. Okay. There's supposed to be 4 DBNs here, and accidentally the first one is being added to the headers. Well, why is that? Well, when I wrote the headers, what did I miss? What did I not add onto it?
A new line.
A new line, right? A new line. So it's giving me some weird functionality. Once I added the first item within the all data, it wasn't adding that new line. All right, so let's go ahead and run it again. This should update my CSV file. And there we go. Now we get what it should look like. The headers are perfectly fine. And we see all 4 of these DBNs within here with their respective school and their data. What do y'all think? Questions?
Can you go back to your Python file? I got confused on your line 23. Where did you get those numbers from again? You did that?
This is coming from the README. The README had like an example, right? For example, your class should be used like this. I just grabbed this random example they gave us, and I created that list here. I passed in that list of DBNs to try out my save as CSV method.
Got it. Thank you.
No problem. Questions, guys?
Yeah, I think in the README it says it should be sorted as well. Where would you, or how would you sort that?
Sorted in ascending order by DBN. So what has to be sorted? You may assume that all DBNs in the list past your method are present in the JSON file. The rows in the CSV file must be sorted in ascending order by DBN. That's super easy. You would sort it. You would sort it here. Right. So after you write it in there, you can sort these lists, the keys. Essentially, what would happen is, does it have to be saved in the CSV file or in here? The rows in CSV must be sorted in ascending order by DBN. Oh yeah. So you would sort it here. I mean, whenever you pass this in, you can grab the list of DBNs and just like sorted DBNs is equal to sorted list of DBNs. I mean, nothing difficult here. It's still gonna look them up in the same manner that you pass them in, right? We're looping through that list of DBNs, so you can sort it wherever you want. You can do it here, dot sort. Right, so for DBN and list of DBNs dot sort, this will loop through a sorted list of DBNs. And if I'm correct, it should sort it effectively. Let's actually see that work for you. Let's go ahead. For DBN and list of DBNs dot sort. And I'm gonna print out that DBN so we can kind of see how that works. Print DBN. None time is not iterable. Why? Let's do sorted. List of DBN. There we go. We see, look at it, right? The first one we got is 0, 1. So obviously this one prints out first because it's 0, 1, right? And then it goes to the 0, 2s. Notice that they're all ends afterwards was still the same, but the next letter or number, we see that sorted 2, 3, 4. So it does sort it in ascending order. Make sense?
Yeah, thank you.
Yeah, no problem. Yeah, so you sorted prior to actually looking for them. And then as it looks for them, because they're already sorted, it's gonna save them to the CSV file sorted. Other questions?
When we looped through the DBN lists and the init method, would it have been possible to do slicing to make that easier?
Slicing.
In line 10.
Yes,
Yeah.
definitely you can.
Yeah, okay. Okay.
We would have sliced it and it would return to us a list, yes. But you still have to format it, if that makes sense. Right, I wanted to format every individual one. So not every individual, but most of them, right? And notice that if you remember the error I got here, it said that this only takes one parameter, right? Before these were passed in as a whole list, because look where how the DBNs are being passed in. It's within a list, right? Before I put these brackets here, I was getting an error, and we can see that here again. I can take all these brackets, and I run it. And it says the string.join method takes exactly one argument. 6 were given, right? So this had to be passed in as a list, right? This had to be a list. And then within that list, I had to format it some specific ones. So could I have used slicing? Yes, but that would have only gotten me from start to finish. But obviously, I didn't want to grab the default version of whatever index 10, 11, 12, and 13 were, because I had to format them to take into account that they weren't strings, they were integers, and also take into account that they were sometimes being passed in as empty strings or none type. So that's why I didn't use slicing. If it was something else, I could have used the slicing, but it essentially it is situation dependent. And because I needed to format them, slicing wouldn't have made sense in this situation. Does that make sense?
Yes, sir. Thank you.
No problem. Anybody else, guys? I know this was pretty heavy. That actually kind of took up most of our first hour of class. But because it is a very intense one, and also because this specific assignment, guys, is going to be very similar to what is going to be expected from you during your assessment, right? Hint, hint, hint. You are going to be given some kind of object or CSV file that you're going to have to format. It's going to be a lot of data, very similar to how you see here, guys. Not just this specific object, but something very similar to this that you're going to have to parse through, grab information, and format it to create something, whether it's a dictionary or an object or to create a class that's supposed to take in certain parameters from a JSON. Yes, the first assessment, Jesus. Right, this is a very important one. So I hope you guys understood how this works. If not, you need to go back and rewatch this video and understand it. If you have questions right now, ask them, because the assessment is going to use something very similar to this. All right, that's the only real hint I can give you about some of the stuff that's going to be asked from you. So make sure you guys understand classes and objects, how the classes can be initiated, and how the init method can open up and read CSV files. Right, you can do actual functionality. I mean, you just saw me do it here within the init file. This is, I don't know why this is not supposed to be indented the way it is.
So Roger, when we get ready to do our own assessment, or as we go through this in practice,
Oh, yeah.
would it be best for us to break line 10 down a little bit more so we can fully understand it? Because I know it looks like you just jabber a lot of code into one line. Would it be best for us to practice breaking that down a little further?
Yeah, so essentially, the part that got very confusing is this, not really needed too much. The best way of explaining it, I did it all in one line, but this can be broken down into multiple lines. Let's actually do that. Right, let's go ahead. I'm gonna undo that. Essentially what I was trying to do, guys, was create what you guys saw earlier was a pre-formatted row with the DBN school name and all 4 numbers right off the bat, right? So I hard coded that. But what's another way of doing that? Well, let's see. We have, let's print out the DBN list. Print DBN list. Let's look at our data again, so we can kind of visualize what the heck we were working on and why I did what I did. Right? We print out our DBN list, and it's giving us a list of lists. Right? Index 0 is useless to me. I didn't need index 1. I didn't need index 3, 4, 5, 6, 7, or anything around 7 and below. What I was looking for was at index 8. With each list within this big list that I'm currently looping through, they all had at index 8 a DBN number, and that's what I want. I need to grab that DBN number, save that as a key in my dictionary, right? That way I can go back and access the values within that dictionary just using the DBN number that was given to me, because I know per the README, it says, hey, you need to take this list of DBNs and grab those DBNs from each of these lists and format me a CSV for the data that belongs to these DBNs, right? So that means I should probably make this object with key value pairs with the DBNs saved as the keys. That way it makes it easy for me to access the information, right? So that was the first step that I had to do. We saw that here. Formatted SAT data is equal to, notice the key that I saved in it. DBN list index 8, right? I save that DBN as the key. Now, what should the value be? Well, I know that I have this list of DBNs that I'm gonna use to have to find information. So with each of these DBNs, I'm gonna pass it into my object, and it should return to me the school name, the number of test takers, and the 3 means. So I'm going to save all that information as a value. So when I call it by the key, it returns to me the value. And what I did here on line 11 was pre-format that all into the string that looked very similar to how my CSV document was. I hard-coded it. So how can we do that differently? Well, I can do something very similar to this. I can say, I can make something like this. DBN, no, I can say school name is equal to DBN list. Well, where was school name at? Index 8 was the DBN. Index 9 was school name. So this will be index 9, right? I can say number of test takers is equal to DBN list, index 10. What was the next mean? It was supposed to be critical reading mean. Critical reading mean is equal to DBN list index 11, and so on and so forth, right? Mathematics mean. I can save them all into individual variables, right? And then the last one was writing mean, I believe. And this is going to be index 13. Remember what happened when I was doing it here? I was getting an error because everything after index 10 was a number. So I can already pre-format it here. I'm going to say string. So whatever index 11 is going to be a string. Whatever is index 12 is going to be a string. And whatever is index 13 is going to be a string. Right? And then what did I do? I joined these all together. So this could be my new formatted SAT will be DBN list index 8, because that's supposed to be the DBN, and I'm saving as a key. It's going to say, I'm going to do the dot join method. What am I joining everything within these parentheses? It's going to be all of this, right? It's going to be joined together with a comma. We already know it only takes one value. As a matter of fact, we can actually manually do this, so we don't use a dot join method. This could be, we're gonna do a formatted string here. so you guys can see it. It's gonna be a formatted string, because that's what essentially everything that we just did. Dot join, all it does is format the string for you, right? It takes whatever's being passed in as parentheses and formats it in a string, and you use whatever is here as how you're gonna separate the items that you're being passed in here, right? So essentially, this right here is the same as a formatted string. So let's just manually format this string so you can see what I was doing, right? What should be the first item that's supposed to be in here? It's supposed to be DBN list index 8, because it's supposed to be my DBN, right? That's the first column that I'm supposed to have. And then it's supposed to be what? It's supposed
Can
to
you just
be
call it by the variable that you put it in now?
correct school name, correct. Then what is it? Number of test takers. That's all I really did on line 17 that I commented out. I just made a formatted string. It just looked a little complex with the way I did it because I was using the dot join method. I should have kept it this way so you guys can understand using methods that you guys are familiar with. But all I did was I just did this. I just created a formatted string, guys. Right? Writing mean. Now let's go ahead and print this out, guys. Let's print out whatever this is, because it should be saved now. Let's print. And let's see what it gives me. Let's clear this out. Boom. Same thing. Notice there's something wrong here. It's giving me none, right? I didn't take care of that here like I did within the dot join method. So there, I'm still getting dot none. We can do that in a bit. But essentially, what I did earlier, guys, with this code right here that I commented out is the exact same thing as everything that I just did right now between line 11 and line 16. It's just a formatted string. That's all I did, boys and ladies. Does that make sense to you?
Yes, I appreciate you breaking that down.
No problem.
Like that.
So yeah, line 18, the one that's commented out, don't fret about it. All right, that's not really too important. All I was doing, guys, was formatting this data for me, right? So I can reach the end goal of making that CSV how I needed it to make. So the important part really isn't how I use the dot join. The important part is understanding that within my init method, I was able to read and write into a file, right? I was able to do for loops, right? I feel like people, they think that class and object, like, oh, the init method is only for declaring data members strictly. That's it. No, you can do some functionality here, guys. You can do stuff, right? It's another method. It's the same thing as a method. It's the same thing as the save as CSV file. It's just another method. It's a very specific method because this will automatically run the moment you instantiate it. Yes, right? That's the biggest difference between these two methods right here, the init method and the save as CSV file. Is the difference is that the moment this class is being instantiated into a variable, the init method is the first thing that runs, right? Because it's initializing. This is how it creates that object for you with whatever the init method is holding. You can still do for loops. You can still do functionality. You can still assign things to data members or different data structures like dictionaries or lists. You can still do all that within here, right? Still do that. The biggest difference that separates that is the fact that this runs on its own whenever you instantiate, and also this is where you would create your self._data members. But you can still do everything else in here. All right, so be able to make sure that you understand that concept, that you can do this in here, right? And then the concept of how to open and read files, of what we did here, of how we wrote into this file using the alias that we assigned to the file, and then using the .write method. Understand that it's supposed to be a text document essentially. And after you're done writing a line, you need to ensure that you write or you add the /n to create a new line, right? You have to manually do that. All right, make sure you guys understand that concept. And understanding JSON.loads, right? How you import JSON data and so on and so forth, right? That's the important concepts you guys need to understand. Alright, guys, it is 6:35. Let's go ahead and take our first 10-minute break. I'll see you guys at 6:45. Alright, guys, let's go ahead and come back. Uh, who completed pets.py over the weekend? Let me get a thumbs up as a reaction. I see James might have started. Uh, who did complete it? Okay, I see nobody except James maybe started. Okay, that's good. We are going to go ahead. We'll take some time to work it, and then this will be our last assignment for classes and objects, guys. Our last assignment. This will kind of tie in classes, objects again, as well as like exceptions, right? So creating errors, then reading JSONs, um, creating JSON objects, right? This will be the last assignment. It's nothing too heavy. Once we're done with this assignment, we're gonna go ahead and move forward to lesson 11, which, if I recall, should be data structures. What is it? Lesson 11 will be big O notation and common problem solving patterns, right? We're gonna shift gears completely after this lesson. So make this one a good one. Try your best. Time is 6:46. I'm gonna give you guys until 7:05. And then after 7:05, we'll do our last walkthrough through this code, and we will move forward with the lesson. All right, so give that a try, guys. Ask questions if you have them, and I'll be here if you guys need anything. My camera will be off because I pig out while you guys are eating. I'm sorry, working. I eat dinner. So let me know if you guys need anything, and I'll unmute myself and turn on my camera. If not, you guys are welcome to start. All right, guys, this will be the last assignment for objects and classes. Let me know if you guys can see my screen. Good, good. Anybody?
Good to go.
Awesome. All right. So for this project, we have to import JSON module. We're gonna take it to the top again, guys. Straight from the readme, import JSON. All right. And we have to write a class named neighborhood pets that has methods for adding a pet, deleting a pet, and searching for the owner of a pet, saving data to a JSON file, then loading data from a JSON file and getting a set of all pet species. It will only be loading JSON files that it has previously created, so the internal organization of the data is up to you. Okay, so we're gonna create our class called neighborhood pets. I think that's how you spell it. And then we have to have an init method, right? Here's our line 5. It's gonna be our init method. So define init, taking self, and it takes no parameters and initializes all the data members, which all must be private. So takes in no parameters. And now, what should this be? All the data members, which all must be private. All right. So it says that the internal organization data is up to us. It should be all pets. The add pet method takes the parameters and name the pet, the species of pet, and the name of the pet's owner. And we need to add it somewhere, right? So we need to be able to save all these pets. Well, the class is called neighborhood pets. So essentially, this class should be able to save other people's pets in here and keep a log of them all. So let's create a data member for it. We'll call this all pets. And we already know that dictionary seems to be the more effective manner of doing things because it's easier to access. So we'll create dictionary, right? All right. Next can be our add pet method. So define add pet. And it takes as parameter the name of the pet. So pet name. Pet name. The species of the pet. So pet species. And the name of the pet owner. Pet owner. if a pet has the same name as a pet that has already been added, then the function should raise a duplicate name error. All right, so somewhere along my functionality, I need to see, hey, does this pet exist within all my pets? If so, raise this error. If not, then add it to all my pets, right? So I know that. So let's go ahead and define this exception. We already know how to do that. We're gonna do class, duplicate name error. And because it's an exception, we have to inherit from the exception class. All right, so it's gonna be open and close parentheses, add exception in there, and all we need to do is just put pass, because all we're trying to do is get the functionality of this class being an error, right? We want to be able to raise this. And the only way for it to recognize this as being an error is by making it into a class and inheriting from the exception class. By adding this within here as an inheritance, this automatically makes this into an error, right? So we see, hey, is this pet name within self.opPets? If so, raise this error. Else, add it to self.all_pets. So we're gonna say if pet name in self.all_pets, I should say raise duplicate name error, right? And then we'll print something out that says pet name already exists in the neighborhood, right? If it exists, raise the duplicate name error. Else, I want to self.all_pets and save it within here. How should I save it? Well, let's add the pet name within here as the key. And then save the value. We'll save the value as another dictionary, right? This dictionary will have keys. One key can be species. And then we can save pet species in here. The next value can be owner. And we'll say pet owner in here as a value, right? So all pets is a dictionary with keys being the names of the pets and the values of those keys being the species and the owner that belongs to those pets within another dictionary, right? So dictionaryception, right? A dictionary within a dictionary. Cool. We can also change this here, this duplicate name error. We can do a try and except block like we've done before. We can say try this, and if that doesn't work, except should be duplicate name error, and then we can print here pet already exists within the neighborhood, right? We can do something like that too. Either or will work. We'll just put it back to how it was. It keeps it nice and simple. But either one works. Whichever route you guys took, it don't matter, right? I'm just not a big fan of trying to accept blocks because it traumatizes me whenever I get errors, so I like to avoid them. So this will be just fine, right? There we go. So the add pet method has been created. So if it's already in there, raise a duplicate name error. If not, then add that bad boy in there. Cool. Next, the delete method takes as a parameter the name of the pet and deletes the pet. All right, so define delete pet as self, and it takes in pet name. And we should say if pet name in self.all_pets, we're gonna check if it's in there. Then so I want to delete it. And we've already covered this during our Python crash course of how to delete stuff from dictionaries. You use a delete method, the DEL, and then you call it by the key. All right. Is there supposed to be an error here? No other error. If you want to, you could create an error here, right? If it's in there, then do this. Else, we can create a new error, raise, non-existent pet, whatever you want to do. But we don't need to do that. But I mean, it would make sense, right? If it's not in there, we should get some kind of feedback. So why not do that, right? Else, raise non-existent pet. We can define that up here too. Alright. These are just things that you guys can do on your own. Existent pet. By taking in the lessons you guys have learned already. Right? And this method will let us know if there's something happened here. Raise pet error. Pet does not exist. Right? I mean, not needed, but that's just another thing that you guys can add to yourself when you guys are making your own code. You guys can make your own exception errors and catch stuff like that to add some functionality so for your program in case you get some errors. It makes it easier once you guys start programming your front end. If you guys are trying to create stuff, see if your front end is working. Are you not getting any feedback? Well, you've already established in your back end that whenever something happens like that, it gives you an error. Therefore, it adds some transparency on what's going on with your code in the back end. So this is more like a service to you guys as developer to see what the heck is going on. Right? Okay, next we can do the get owner, right? So define get owner. The get owner method takes as a parameter the name of the pet, so self, and then pet name again, and returns the name of its owner. So it should be, once again, we're gonna check the self dot underscore all pets. If pet name in self dot underscore all pets, then we want to grab it. We should be able to return the owner. Return self dot underscore all pets. Put in the pet name as the key because that's how we defined it. And then what are we gonna grab? We gotta get the owner. So the next item within here, because it is a dictionary as a value, we need to say owner, right? It can be owner, or we can even use the dot get method, dot get owner. Either one is fine. We'll keep it simple like this. So with what you guys know, using the bracket notation, we went inside a pet name. It returns us a dictionary. That dictionary has key value pairs. One of the key value pairs is owner with the name of the owner. So the next thing we do to grab into that dictionary is by using bracket notation again and grab that owner. Right? Else, we can say non-existent pet again. Else raise non-existent pet. Right? We just reuse the exact same error because obviously if the owner is not in there, that means the pet doesn't exist because the only way to add a pet is by giving this bad boy an owner. We can say again, pet does not exist. Right? We can use the exact same error we had before. If we don't find an owner, the pet doesn't exist. All right. So that gets the get owner method. That's done. Now is the JSON part of it. Right? So now we have to create a save as JSON. Right? So let's go ahead and create that method. Define save as JSON. And this method takes as a parameter the name of the file. So name, oh, I forgot add self, name of file. Right? It takes in as a parameter the name of the file to read and loads that data. This will replace all the pets currently in memory. Right? So, oh, I'm sorry, I read the wrong method. Line 9. This should take the parameter, the name of the file, and save it into the JSON format with that name. You can assume the extension, if any, will be part of the provided name. You can organize your JSON file however you want. Right, so we can just go ahead, we can keep it simple. We can say with open, right? Because we're gonna go ahead and write into this file. So we have to use the with open. We can assume that the extension is already gonna be added within the parameter here. So what does that mean? Well, whenever we call this method, it should the whole name as well as the extension needs to be added within here, right? We can assume that thanks to this readme. So honestly, we don't have to do any kind of formatting here. We can just pass in name of file. If we couldn't assume that there was an extension here, then we would have to do some formatting, right? We would have to do F, open and close quotation marks, add the name of file, and then do like .json, right? But we're gonna go ahead and assume it's part of it. So we don't need to do that. We could just do name of file. I'm gonna write into this file. Because we're writing out into this file, we're gonna say as out file. Right? We're gonna give it the alias as out file. Now, We've already loaded up data before in the last assignment. Now we have to dump data into it, right? So to dump data into it, we use the JSON.dumps method. So we're gonna say JSON.dump. But what do we want to dump in here? We want to dump the dictionary self_all pets, right? Am I correct? You can already okay, so we're saving as JSON. It takes primary the name of the file and saves it in the JSON format with that name. I'm assuming we're just saving all this information in here. So we're gonna do self.all_pets, right? I want to save it where? Inside of our out file. Right? So it takes two arguments, what you're dumping into it and where you're dumping it. We're dumping it into out file. Okay. Pretty straightforward. Next, we also want to be able to read our JSON file. So we're going to say define read JSON. Right? The read JSON method takes as a parameter the name of the file to read and loads that file. This will replace all the pets currently in memory. Right? Currently in memory. That means, right? Let's say we instantiate this neighborhood class, right? Neighborhood pets class, a brand new one. It has nothing added within it, right? Self.all pets is empty, but we have a JSON file that has a JSON object in it that already has pets with species and owners. That means we need to be able to take that information in, overwrite anything, if there is anything in there, and save it into our data member. So we're gonna add name of file. And next, we're gonna go ahead and open that file up. We're gonna say with open, I want to open up the named file, and we're gonna be writing into it. Oh, I thought it was, are we writing into it? No, we're reading into it. We're reading into that file. All right, because I want to grab the information from there. I don't want to write anything into it. I just want to be able to access it. All right, so I want to read into that file, and I'm gonna give it the alias as in file, right? Because we're grabbing information from it as in file. And then we want to overwrite anything that we might have already pre-existing within our all pets data member. So that means we should be able to do self._all pets is equal to, and then within here, we will do JSON.load. What do we want to load? We want to load our in file in here. So it should go within that in file, grab all the information, and loads it into our all pets data member, right? All pets data member. Right? And then let's go ahead and print that out to ensure that works. So we'll add a method here to print out all pets. That's just so I can see and make sure it's working, right? All right. Lastly, the get all species method takes no parameters and returns a Python set, right? A Python set of all pets. The research what it said is we haven't covered in class. We briefly covered it, but we'll do it here, right? So we're gonna do define get all species, taking self and no other parameters, right? It returns a Python set of the species of all pets. So we're gonna go ahead and create a new variable called all species. We'll add it into a list, right? Because there might be multiple of them. And then we want to grab all the species within this dictionary, all pets. But we know it's a dictionary. The keys are animal names, right? They're pet names. Each key has a value, the value being another dictionary, and within that dictionary is a species. So I have to loop through all these pets. So I'm gonna say for pets and self.all pets, right? I'm grabbing the pets. I'm gonna say all species, $pen. I'm gonna add within this list the species of whatever those pets are. So I'm gonna say pets, and I'm gonna grab the species. Right. Once again, what is pets? Right. These are the keys, For keys in self.pets, these are names. The value is a dictionary. That means whenever I access anything within pets, I have to use bracket notation because it's a dictionary. And I'm trying to grab the species one, right? This is what we're going into, right? We're using the pet and it's returning this, a dictionary with species and owner. We want to grab species. Once it grabs species, we append that into the all species list. And then all we are going to do is return all species, but we're going to do something specific here. We're going to wrap this around a set wrapper, right? A set. To convert something to a set, all you have to do is wrap it around the set wrapper, right? It'll convert everything within here into a set. Now, let's see in action. I know we went through that very quickly. We're gonna go ahead and do, we're gonna create our, actually, we should be able to just save all this. Let's take it one line at a time so we understand what's going on. This instantiates our class. We're going to try to add these. Notice this is using the add pet method. It gives it a name, a species, and an owner, right? That's exactly how we create it. Pet name, pet species, and pet owner. It's trying and doing the except block as well to see if it can catch the duplicate name error. Right? This shouldn't be an issue because obviously none of these are duplicates. So let's go ahead, copy this down here. All right. So far, so good. And then just save it as JSON. Let's do up to this part so we can see how that's working before we start deleting stuff. Save as JSON. I'm gonna go ahead and run this file, guys. CD pets. Then it's Python pets.py. Okay. I ran it. On the left side, something populated on my directories, pets.json. That means that I was able to successfully create this neighborhood pet class. And by using the add pet method, it created all pets and then it ran save as JSON. So it created that JSON file, guys. This is the name of that file, pets.json. It created, let's look at it. Okay, we are getting something here, but it does not look sexy, right? It's all within one line. We can add some functionality to that. If we go back to our save as JSON method, the JSON.dump, it takes a third option. We just didn't use it. The third option here is indent. We use indent, and if we set indent to 2, it's going to indent the different keys here, the different levels of what our stuff is doing. Run it again, it updates it. Notice that now we have some kind of formatting here. Now it looks like an actual JSON object with some nice pretty formatting, and we can see the nesting happening. We see the first object is the overall top layer. It holds 3 different things within here, 3 different keys, fluffy, tiny, and spot. The values are other objects within it. One being species and one being owner, just like we declared. All right, so that is working. Now we're gonna run the np.delete pet. We're gonna delete tiny. This is gonna be no longer, guys. Coming down here, we paste it, run it again. It is not doing what it should be doing. Let's try it again. Delete pet. Why did it not work? Took in pet name. Delete sub all pets. Okay. Okay, I see why. We delete the pet, right? But we never update the JSON file. Or we never delete the JSON file. But let's check what our pet's even in there. Do we have a get method for that? We do not. So we're gonna have to directly grab all pets just to see if it's working. Let's just grab that data member and see if it's doing what it should be doing. Let's print it out. Print. Okay, here we see the JSON and we don't see tiny. So it did what we were supposed to be doing. But why didn't we see it in our pets.json file? Well, because we saved it originally with tiny. We deleted it from our dictionary that's in our data member, but we never updated that JSON file. That JSON file stays the same. It's not connected to anything, right? We never ran another save as JSON, right? Never ran another save as JSON. What did we do? np.save as JSON after we delete tiny. Well, after we delete tiny, we run it again. Why is it not saving? Oh, I'm stupid. I did not add the file name. Save.json. All right, now it should work. Run it again. There we go. Save as JSON. It updated it the second time. Notice that Tiny is no longer with us. He's in a better place now, guys. Okay, cool. It's doing what we should be doing. Let's go ahead and remove the second save as JSON and move forward with the example. Next, we create a new owner, right? Spot owner is equal np.get owner. Oh, we're not even creating a new owner. We're grabbing an owner that currently exists already. Let's print that out to make sure it's working. Spot owner. Notice it returns with Farok. I think that's how you pronounce it. Right here. So it's working. It grabbed the owner of spot. So get owner is working. Notice we're now going to read the JSON. But what's happening here? They're trying to read a file that doesn't really exist. I think when Yema made this, he had an additional file. For other pets.json is a file it's saved in some previous session. It shouldn't work because it's reading, not writing. So if you run this, we're getting an error. See, no such file or directory exists, right? Because we're trying to read a file that does not exist. So we'll just skip that for now because I'm not going to create another file. Let's go ahead and use the species set and then print this out to see what the set looks like. String indices must be integers. Oh, my bad. I can't print when I'm saving a variable. Print species set. Append species. Okay, I'm trying to append string indices must be integers. String indices must be integers on line 47. I'm trying to append species, but it's not working. It's saying it has to be integers. Why is it saying to be? Did I misspell something? Maybe because I didn't put keys. Is that why? No. Let's see what this is giving me. You're watching me debug in real life. Let's print this out. It prints out Fluffy. So it's grabbing the name for sure, right? It's grabbing the name. But it's not a key, it's just a name. So essentially I have to do dot values to grab all the keys. So for pet data in self.all_pets, this will return the values. Let's see what pet data is giving me. Print pet data. Name pets is not defined. Yep, I'm getting error here, but did it printing out? Yes, it did. Notice it printed out the values, which is species. So now we can do pet data. Run it again. There we go, guys. Now I get something. Now I'm getting, let's go ahead. Can we delete line 47? There we go. I'm getting Gila Monster and Zebra printed out. What is this? Let's use type within here to see what it prints out back for us. Notice it's a class set. So it is a set. This is how it returns to us. We got all species. We have Gila Monster and Zebra. Notice there's only 2 because we had delete it little tiny. If we get rid of this, you'll see it change. Let's get rid of the type again. There we go. Zebra, Gila Monster, and Stegosaurus. Awesome. Good stuff, guys. Do I have any questions? Any questions at all? All right, guys. If I have no more questions, this concludes lesson 10 and finalizes our object and classes lesson. This is it for classes in object-oriented program in general. The next class we have is Big O notation and common problem-solving formulas. It's not as sexy, but it's still very important to understand how your code is working, and it'll make you think a little bit more critical with the way you write code, right? So it's a very important lesson. It's very common to get questions about Big O notation. And common problem-solving formulas is going to be your biggest gate to cross through when actually successfully making it through the immersive program, because I know every single one of you guys will. This gate is what's going to keep you between you and a job. So it's very important that you guys pay attention to this following class. Time is 7:35. Let's go ahead and take our last 10-minute break of today. I will see you guys back here at 7:45. Hey guys, sorry, wait 1 minute over the time. I was taking my dog out and he likes to smell every freaking flower on the way back to the apartment. So let's go ahead and pick up from where we left off, guys. We just finished lesson 10. We will now begin lesson 11. You guys are more than welcome to follow along with your own slides or just pay attention to what I got on my screen. So lesson 11, Big O and common problem solving patterns. All right. So how to judge quality. Imagine we have multiple solutions to a coding challenge. How do we decide which solution is best? Who can take a quick guess? What do you guys think? How do you identify whether my solution is better than Kim's?
The
Yours will
number,
always be better.
What was that?
I was gonna say the number of lines of code as far as making sure that nothing is duplicated. That you're
Okay.
using the right methods, if I'm available, things like that.
How about you, Kim?
Well, I was gonna say yours is always gonna be better, but also the lower it is, the lower the number on that complexity, the better.
That's a cheap answer, but okay. The lower complexity, yeah, of course. You know, the lower the complexity that we have here, right? He can't answer the question with the term, but good try, good try. All right, so
Well,
Big
the
O,
less times you loop through, maybe the
We're
less
getting
times you have to
closer.
loop through. Like if you have a nested loop, then you have to loop through a loop.
Yep, that's very close. You're getting to it. Absolutely, absolutely. Right. So Mike, good try. Big O is a mathematical notation that allows us to compare algorithms to one another, right? Big O notation is the example for that is you see it here. We have a small chart going from top to bottom, bottom to top. The complexity, the one at the very bottom is the less complexity. What is complex? I mean, how complex of how many steps it takes, right, to reach its answer, right? The higher the complexity, that means it's taking more steps to reach a certain answer, right? O1 being the least amount of complexity, that means it's typically instant to reach a solution, where the higher in the scale, the more steps your code is taking to reach that solution. And it'll make a little bit more sense afterwards. We also see here the actual naming term for each one of these. O of 1, we call that constant time, right? O log of n, logarithmic. O of n, linear. O n log of n is n by log of n, quadratic, cubic, exponential, vectorial, so on and so forth, right? So they have specific terms that go to it. The one you'll hear the most will probably be like constant time, linear time, logarithmic. Those are the most common ones you'll see. Anything past that, it gets way too difficult and your code probably isn't that efficient. And we're gonna learn a little bit about this, so enough for you guys to get a nice warm and fuzzy of what the heck log of n is, and for you to start thinking critically about how you are coding your programs. So why is this important? So it is important to have a precise vocabulary to talk about how our code performs, right? So this is when it comes from developer to developer, when you're talking to your project manager. It's useful for discussing trade-offs between different approaches to a given problem, right? So just because your code might look prettier does not mean it's as efficient as mine. Might be more of a mess, but theoretically, it might be more efficient than yours because of how it's being solved, right? At bigger companies, you will be dealing with very large data sets, or the implementation of one algorithm over another might save you a couple hours every time it runs. And we all know time equals money. Example, we want to write a function that doubles the integer that is passed in, right? Without cheating and go on to the next slide or whatever, who can guess which one of these functions is better?
The right.
Why?
Because it's short and straight to the point.
Not necessarily short. Short doesn't have anything to do with it. Take another guess.
Well, the one on the left is an iterator, while as the one on the right, it's just gonna perform the math calculation.
Yeah, exactly. Iterable, or the term that you use, right?
Yeah.
That's honestly the keyword right there, right? So on the left, we have pretty much the exact same function, do the exact same thing. The only difference that the left is doing is that it's doing a for loop, right? The loop itself is the biggest giveaway, right? Where the complexity is going to depend on how big num is, right? Whereas on the right side, no matter what the num is, it's just gonna do one equation. Straight to the point, it was just gonna get whatever num could be 1, num could be 1,000,000. It's gonna be just multiply that one number once. That's it. And it reaches that its solution. Whereas on the left, right, we are looping through however big num is, right? If num is 1,000,000, right, it'll loop through in the range of 1,000,000. So this will do it. This for loop will loop through 1,000,000 times until it reaches its total, right? On the right, does not matter. It does not matter if it's 1,000,000 because it's only going to multiply it once by 2. That's it, right? So on the right, it took 1 step to do this. When we talk about big O notation, we talk about steps, not time, how long it really takes. We talk about steps. And you'll see that more frequently right now as we continue with the slides. On the left side, we are looping through and doing in multiple steps. This will not reach its endpoint until it reaches whatever size num is. Num can be 1,000, num could be 1,000,000, num could be 2,000,000. If it's 2,000,000, it's gonna take 2,000,000 steps. Here, doesn't matter if it's 2,000,000, it's only gonna take one step every single time, right? What do we mean by better? What code is faster? Which one uses less memory? Or which one is more readable or even less lines of code? What do you guys think?
I would say faster. Or all the
Okay.
above, even.
I like the second answer. All the above, right? So I think all three of these are important. Which ones is more important? That's the next question. I think the one that's the most important is which code is faster. But at the end of the day, all three of these have their importance, right? It's good that it's fast, but if it uses too much memory, or even worse, if you can't even read what the heck is going on and it's super confusing, and that can make it very difficult to use for other developers or to even understand what's going on, especially when it comes to debugging or collaborating with others, right? Which code is faster will be your number one priority, right? I think second will be which one is more readable and less lines of code. And third will be memory. Memory is not as important as it used to be 20, 30 years ago, right? If you guys grew up with a PlayStation 2 like I did, you might remember this. When I was younger, right, I got my first PlayStation 2. All right, my mother bought it for me. But if you guys ever use it, you would know that you needed to buy a memory card, right? And this memory card is what saved your progress. Without this memory card, you would have to restart from the beginning every time that you loaded up this game. The memory card itself is what kept track of your progress and allow you to actually restart from where you last left off. My mother bought me the memory card, and at the time, it costed like $50. I don't recall exactly how big this memory card it was. It was somewhere around like 12 gigabytes. About a year ago, I bought a terabyte for my laptop. A terabyte cost me maybe or somewhere around 15, 20 bucks. A terabyte, right? The advancement in technology has made memory cost significantly less than it used to 20 years ago. If you would have asked this question a long time ago, memory would definitely be competing with readability, hands down. Nowadays, memory is cheap and is very easy to buy. So I would not say memory is too big of an issue. But it used to be, right? These days we focus mainly on if your code is very efficient with time and is it readable with less lines of code, right? When it comes to lines of code, that also very depends on the language, right? Python is really good for like short programs, right? It's good for proofs of concept if you want to get something out, because it's very English readable and it's easy to code out. It's not as efficient as other programs like C#, C++, but C# and C++ are so complex, they do so much, and you need more lines of code to do the exact same thing. And there's like trade-offs to both of them, right? But yeah, I just wanted to get that out there. All right, so let's talk about which is faster. If two different people run the same function on two different computers, will they get the same time? What do you think, James? No guess? They will not get the same time. It'll always be different, right? It'll always be different, even if it's the same computer. What if the same person runs the same function on the same computer on 2 different days? Will the runtime of that function be the same?
No.
It will not. Let's see if I can give you an example real quickly. If you guys use LeetCode, you might have seen this before. Who's used LeetCode recently? Anybody?
Sorry, what were you saying?
Has anyone used LeetCode before?
I think some of us have touched it, yeah.
Okay. Leak code, when you run your problems, give me a second, I'm logging into my leak code real quick. Leak code gives you the option to check your time complexity in your solutions. And I'm gonna use that as an example. I'm going, give me a second. All right, this is my leak code. If I go to my problems, the most recent one I did, I believe, was a leak code 75. You guys are seeing my leak code, correct? I wanna make sure I'm sharing correctly. Right. I completed these amongst others during my interview preps. We can click it. And it'll take you to previous solutions that you might have done. And when you run your solution, when you submit it, right, it's gonna take you to your window where it's gonna tell you your performance, right? It's gonna tell you on the left side whether it was accepted or not, whether you've successfully solved all these solutions. And then it tells you how much memory and how much runtime you use in your solution. Notice that it took 38 milliseconds for my code to run, right? And it beat 35% of all the other solutions on the site of other people who have coded. It even gives you a description for your memory, right? My memory being 35%. Check, make sure you make a mental note of this, right? 3570, 3501. I can run the solution again. 3570, 3501. And we're gonna see it's gonna change. It ran the exact same code. I didn't change anything. I just resubmitted. It ran again. And this time I ran it a little bit faster, right? And it beat 75% of other people. They even gave me an applause, right? The space complexity stayed the same, but the runtime changed, right? The runtime changed. Let me submit it again. Space complexity stayed the same, right? And you will get to that because I didn't create any more space here. My code has not changed. My time complexity went back down to 3570. It's not going to run the same every single time, even if it's the same computer 5 seconds apart. It does not always run the same. I've not changed it, right? All right, that takes care of that example. Going back to this. So, as you guys just saw, no, right? Even if different people run the same function on 2 different computers, they will get the same, will they get the same time? No, they will not. Even if it's in the same computer, they won't get the same time. Even if it's the same computer, different days, it will more than likely always be something different. If not, it might be similar sometimes, but for the most part, it will always be different, right? And that is why we do not use time, right? We do not use time. We don't see how, like, time-wise, how fast it runs. That's why we do not use time to compute how fast our code is. Different computers will record different times. Even the same computer will record different times, as you guys just saw from my example. For very fast algorithms, the same time measurements of a computer might not be precise enough, right? So how do we identify which is more efficient than others? That is the big O notation. So not time, but we calculate iterations, right? How many iterations, or in another word that I use, steps did it take to reach our goal? Instead of measuring every time, we count the number of simple operations the computer has to perform. This number stays constant across all computers that run the same bit of code, right? Because the code doesn't change. Just like you saw on my space complexity, how much space my code was taking, it did not change because the variables that were declared was still the same. Nothing else was added. So we track it by iterations, by steps, right? This function on the right here is only one operation, no matter how big num becomes. As mentioned before, num could be 1, it could be 1,000,000 or 2,000,000. Every single time, no matter how big num is, it'll only multiply that one number once right here on the second line by 2. One iteration. Let's compare. How many operations does this function run if num is 10?
Nine.
Why?
Well, because range stops at the, well, wait, so range and Well, wait, what's the value of num? How many is function num? So it'd be
It
zero.
doesn't matter.
So it okay, 10. Excuse me.
If num is 10, it's gonna take 10, right? It's gonna take 10 operations, right? What if num is 1 million? Once again, it's going to depend on the size of num. It'll take 1,000,000 operations. Why? Because it's using a for loop. It's saying for underscore in range of num, total plus equals 2. So it's going to do this however big num is because of that for loop. Right? That for loop is making this operation run multiple times within the range of whatever num is. Specific number isn't that important. The only thing that matters is a rough estimate. For this function, the number of operation grows roughly proportionally with num. So however num is will depend how big or how many iterations our code is going to take. Big O, simple definition. Big O notation is a way to formalize fuzzy counting, right? It allows us to talk formally about how the runtime of an algorithm grows as the input grows. Specifics don't matter as much as the broad trend of the function in question. By the way, Anki, probably a good time for you guys to be writing some notes. Right, here we have a chart which you will see multiple times throughout this slide, PowerPoint. You're gonna see different variations of this chart here. We have on the bottom the input size being n, and then on the y-axis we have computations, right? So as the input size grows, we can see how as well with the computations, how these algorithms affect it. Notice that constant O of 1, no matter how big n is, computations will stay the same. And this is your most effectiveness, right? With log O log of n, what affects it the most is how many computations you do. But notice that the higher on computations we have, the faster it becomes, right? No matter what n is. And then we also get to O of n factorial. This is the worst. But this is kind of a nice representation of how this kind of works. This is probably your most accurate one of comparing these. O of 1 is kind of where you want to be at. Most of the time, you'll probably get somewhere between O log of n or O of n. This is probably where most of your solutions are going to be and where you want them to be. Back to our two examples. This example here is what we call O of n, right? O of n. This is O of 1. Now let's talk about these. What is O of 1 and O of n? Well, as you guys just saw, O of 1, right? It's called constant time. Constant because it happens instantly, right? It happens in one iteration. O of 1 is as fast as you'll ever get in all your code. There's nothing faster where it's just instantaneously, it just does one operation. O of n, right? That is your linear time. Linear as in the number of operations grows linearly on the size of your input. What does that mean? Your input is your n, right? Your number. N is your number, right? Your input. Number of operations. The higher n grows, the higher your input grows, your number, the more iterations it's going to take. So it grows linearly with n. As mentioned before, if num is 10, then it's going to take 10 operations. If num is 1,000,000, it will take 1,000,000 operations. N is linear. This is not the best, but it's better than most. Right? O of n being the number of operations it could possibly be. We're talking about worst case scenarios here, guys. Worst case scenarios. Obviously, if some for loops, we might reach the answer on the first iteration we do. For example, let's say we're looping through a list of numbers, right? And it'll be O of n because we're doing a for loop through a list, right? So n being the number of items within that list. We have to loop through every single item to reach, let's say, a number that is equal to 2. Let's say that number is the first number within this list, right? This list has random numbers. It just so happens that the first number we start our for loop is equal to 2. Does that mean it's constant? It does not, because when we talk about big O, we're talking worst case scenario. So yeah, maybe this one time the number we're looking for was at the start of our list. But if our list has a million different numbers, worst case scenario is what if number 2 is at the very end of the list? So when we talk about big O notation, we're talking about the worst case scenario being the last number of iterations, right? Make sense? Broad trends example. Here we see another function, both of these. We have 2 loops, guys. We have 2 loops in the exact same function. The first one is the for loop. It does for up num in range of num. Essentially, it's printing up our number, right? It's gonna go from 0, 1, 2, 3, 4, 5, whatever num is until it reaches its end, right? This is an O of n operation. Why? N is equal to the number of iterations, whatever our input is. N being worst case scenario, num could be 1 million, num could be 2 million. This is also O of n. It's doing a for loop. The number of operations depends once again on whatever n is, n being number, right? Num could be 1 million, num could be 2 million, num could be 1. With 2 for loops back to back, will this make it O of 2n? What do you guys think?
Maybe.
Maybe.
Yes.
I want to guess and say no.
It is a no, guys. It is a no, right? O of n is already taking into account that worst case scenario is that we already have 1 for loop. So we already know it's already going to take O of n, so many operations, right? It's taking into account even if there's another loop within the same function, right? It is still O of n, even though there's 2 for loops in here, right? Right after each other, it is still O of n. Worst case scenario is whatever the biggest number is, right? It is still O of n. It is now O of 2n. All right, a bit misleading. We care about number of operations and not time directly. What is the time complexity of this function, guys?
Is it a O of n squared?
O of n squared. That's a good guess. Who said that?
I did.
I don't know who you. I have my
Daryl.
Zoom. Okay, it is O of n squared, guys. Why is it O of n squared? Well, because for every single n, every number within our outer for loop, we have to do the exact same operations again, right? To the power of 2, right? O of n squared. Does that make sense? If you guys recall for loops, right? Let's say this is 10, right? The outer for loop, this num here is 10, right? And this is 10 as well. This will have to run 10 times, but every time it runs through one of the operations, it has to run this 10 times as well. Let's look at that. Let's look at some code. All right, we're gonna go ahead and create a file here. We'll call this, not here. We'll do it within our lesson 11. We'll call it big O examples.py. Bring create count up, and we'll say num, or we'll say count. We'll call it count. I'm gonna add num in here. And I'm gonna say for I in range of num, print num. What does that give us, guys? Let's see. CD. Give me a second. Python. Big. Okay. Oh, I didn't call the function. My bad. Count. Let's give it 10. Okay. Oh, my bad. Printed num. Man, I'm fried. I've been on my computer all day. Sorry. Go ahead. Do it again. What am I doing? Print I. Here we go. Now for sure, guys. For sure. All right, there we go. We print out I. So we did for I in range of num, we made num to be 10. Notice it prints out 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. It printed out 10 times. If we do a for loop, right? If we do a for loop, we can say now for J in range of num, and now we're gonna print out not only I, but we're gonna print out J. Look what's gonna happen. Right, and you guys should already have an idea of how this is gonna work from your experience with coding. But notice that initially we just printed from 0 to 9, right? But because it's a nested for loop, every time it gets to a number, every time that I runs, J is gonna run and has to finish running before I can move forward. So the for loop starts, right? It starts at 0. Once it starts, the first thing it's gonna do is gonna go into this inner for loop and it's gonna print out J as well. Right? What is J? Well, it's 1. I does not continue going on until this for loop finishes running. So J increases in count. J goes from 0 to 1. It prints it out again. I never changed, but J did. Right? J went to 1, but I stayed to 0. I still does not move forward because J isn't finished running. J goes up to 2. And then we print 0, 2. Once again, it goes back again. J goes to 3. We print 0, 3. And it's gonna do that until this inner for loop finishes running. Once that inner for loop finishes running, then finally I can increase in number. So I becomes 1. But now that we move on to the next number, what happens again? We go back into that for loop. J once again is back to 0. And it does that until it gets to 9 again. And then once again, I is able to increase it 2, and so on and so forth. Right? So what initially was just 10 iterations, now this became 100 iterations, right? Because this has to run 10 times and this has to run 10 times. Therefore, n squared, right? 10 times 10. 10 to the power 2, right? For every iteration that I runs, J has to run that many iterations as well. That is why it's n to the power of 2. Make sense? All right, nested loops. How many operations does this function run if the num passed in is 10? I already gave you the answer. What is it? Oh, it's right here. It's going to perform 100 operations, guys, right? Because this is 10. For I in range of 10, this has to run 10 times. But every time I runs, this runs 10 times. Therefore, 10 times 10 is 100, right? So this has to run 100 times. So if num is equal to 10 and our function runs 100 times, that's n squared, right? N to the power of 2. Time complexity is O of n squared. Make sense, guys?
Crystal clear.
Awesome. I want to make sure we're all able to keep up with this. Once again, here you have another visual representation of the exact same graph we saw earlier. So we're not gonna stick to this too much. We're gonna keep moving forward. Next, simplifying big O notation. So remember, broad trends. What happens to the number of iterations as the input gets really big? Right? So here are some tips. Constants do not matter, right? O of 2n. We saw what O of 2n was earlier. O of 2n, technically, it's 2 for loops, right? Not nested, just 2 for loops within the same file, right? Back to back. Once again, not nested. Does not matter how many, there's 10 for loops in there or 20. As long as none of them are nested, the time complexity of your entire program, worst case scenario, is O of n. Right? O of 500, right? What does that mean? Well, let's say if you recall this function right here, where we did this one operation, we return num times 2. Let's say it's not returning, but it does num times 2 500 times. Nothing nested. It's just num times 2 is on line 2, and then line 3 is the same thing, num times 2. Line 4 is num times 2. Line 5 is num times 2, and it just does that multiple times. That does not matter, guys, right? That does not matter. It is still going to be O of 1. Doesn't matter if it does that operation 500 times. Every single time it does it, only does one operation. One operation. One operation. It is constant. It does not have to do it multiple times in that same line. O of 1. O of 13 n to the power 2. What does that mean? That is 13 nested for loops. Does not matter how many nested for loops you have in there. If they're only nested once, it's still O of n squared. Smaller terms also don't matter. O of n plus 10 is still O of n. Let's say your for loop is doing for I in range of 10 plus 10, right? And it's still O of n, guys. Even if you do a plus 10, it's still dependent on whatever the worst case scenario of this n is. It is still O of n. Same thing with here, where you multiply how many for loops you have. Even if you have 1,000 for loops, right? And each one of those are increasing the n plus 50, it is still O of n. Next one, O of n squared. That means we have a nested for loop. And then we also have a 5 for loops that are not nested. And then we have 8 constant iterations. It is still O of n squared because only like the worst case scenario is that square, that nested for loop we have. Nothing else is nested any further. So it's still O of n squared. Arithmetic operations are constant time, O of 1. We saw that earlier. Num times 2. It is constant time. It does it instantly. Variable assignment is constant, guys. Variable assignment is constant. Right. So when we assign something to a variable, no matter how many variables we assign, it is still constant time. Accessing elements in an array by their index is also constant. Why? Why, guys? If I have list 1 is equal to 0, 1, 2, 3, 4, 5, right? But I want to grab whatever is in index 2. Why is this constant? Even though it's a list of different items. Why is that constant? Very simple. Because it knows where it's at, right? It has a map, it has a link, everything is hashed in memory. If I tell it, hey, go to where 2 is at, it knows where it's at. It doesn't have to loop through multiple things. There's an address to this that links it to this, right? So it just checks the address. That's it. It is constant time. It will do it instantly. It does not have to look through, as a for loop would, through every single one until it finds it. If we were to do for I in range of whatever length of list 1 is, and then said if list 1 is index I is equal to the number 2, then print list I index I, or list 1 index I. That is different because I'm having to loop through every single one until I match that number. This immediately becomes O of n. N being however big this list is. N being the number of iterations I have to do worst case until I find 2, because 2 could be at the very end, who knows? Right? O of n being worst case scenario. Make sense, guys? I'm gonna take as your silence as compliance. Same thing with objects in dictionaries. If we access dictionaries by using their keys, right, it is constant. Once again, it's a map to it. It's an address. It knows where to look. It's using that key to be able to reference it in it. So objects in dictionaries, which is why it's very common to want to use dictionaries. Those are very powerful because we have that key value pair that are linking them together, right? Whereas you don't want to put it in an array because unless you physically know the location of every single item where you want to find something, you're going to have to loop through it every single time, unless you know the index. But more times than not, you're probably not going to know the index of it. So you're going to have to do a for loop and then loop through every single item until it matches what you're looking for, right? Or after dictionaries, typically we know the key values of what we're looking for. We add notes like, hey, you know, the keys are all names. And then we can just pass in a name to see if it's in there. If the address matches, then obviously we found it. If not, then we didn't. But still, that it was constant, right? In loops, the complexity is the length of the loop times the complexity of what happens inside that loop, right? And we saw that in our nested for loop. All right, short quiz. What is the time complexity in big O of the following ones? Right. What is one? Who can guess? Actually, not guess. Who can give me the right answer?
O of n squared.
Wrong. It's O of n. N being the number of operations it has to do, right? How is n dictated? Let's say if it's a list, right? N is equal to the amount of items within that list, right? So let's say n is equal to 10 or 100, right? It does not matter if you slightly increase it by 10. It's still worst case scenario. It's going to depend on how big that list is. So O of n plus 10 is still O of n. Right? Next one. What can you tell me about the second one?
It's O of n.
O of n, guys. This is saying there is yeah, right. Let's say a list is 100, right? It's multiplying that by another 100, making 1,000, but still dependent on how big n is. Worst case scenario, right? This is still just one for loop. You're just increasing the amount of items within that list, but it's not nested. It's still the same for loop. Right? What about the number 3?
This would be constant, right?
O of 3 is constant. It is O of 1. Correct. What about number 4?
It's O of n.
O of n, right? Essentially it's just multiple, the constant looks like a multiplier of the growth rate of what n is, but it's still O of n. It's still worst case scenario, whatever n is. None of this is nested. What about this one? Number 5.
Is that quadratic?
This is cubic.
Sure.
Cubic. Where is that? I'm pretty sure it's to the power of 3 is cubic, correct? Am I dumb?
Yeah,
O
no,
to,
you're right.
O to the power of 3. I'm pretty sure I'm using that correctly. Yeah, it's cubic. What did I do
Looked
with
like
it?
a polynomial for the power of 3. No?
So essentially, the highest growth rate is 3. It's 3 for loops, right? 2 of them are nested. So it's to the power of 3. Whereas before, when we had only one nested, we had to do everything within that one to the depending on the amount of times or whatever the initial for loop was. All right, so the essentially it's O of n3 or to the power of 3. Cubic. Cubic? I think it's cubic. I'm pretty sure it's cubic. Yeah, that's how yeah, it's cubic. Don't confuse me. Number 6, function with one set of nested loops. What is that? One set of nested loops. What is that? You know this, guys.
N squared, isn't it?
O of n squared. Correct. O of n squared. What about number 7?
Just O of n.
O of n. Does not matter how many there are. None of them are nested, right? And there's 10 of them. It's just still O of n. Worst case scenario, whatever n is, or the worst one of them. Another quiz. What is the time complexity of the following function?
Is it O of N?
O of N, correct. It starts at 1, but none could be 10, none could be a million, it does not matter. O of N, right? It is dependent on whatever the size of num is. Another quiz. This is a little confusing. Actually, I get confused every time I do it. This is a trick one.
It's still just gonna be O of N, right? It's just gonna loop through it once.
Why is it O of N? It's just gonna loop through it once. Think about it. What is it doing here within that range function? What is min doing?
It's finding the lowest number.
It's finding
In
the
that
lowest
range.
number in that range, correct. It's getting the lowest number between num and 10. What if num is a million? What's the answer gonna be?
Well, the min will be 10. Right?
It'll never be anything higher than 10. Never be anything higher than 10. So essentially it will be O 10. If you think about it, right? It's capped at 10. There's not like it will never be anything higher than 10. Right? So worst case scenario is gonna be 10. So O of 10, therefore making it O of 1. It's like having multiple actions of O of 1, if that makes sense. It runs a fixed loop only up to 10 times. When we think about O of N, we think about worst case scenario because we don't know what N is, right? We have an unforeseen amount of complexity. It's all dependent linearly wise to the size of whatever our list is. But O of N could be a 2, it could be 100, it could be a million. Who knows where our answer, what we're doing for is looking for, right? But here we know no matter what, it'll always be 10. Therefore, it cannot be an O of N because it does not grow linearly to what num is because it's capped at 10. It is capped at 10. It does not grow linearly with num because of this min. Does that make sense? Technically, it's 11 because O of N, it's plus 1, but yeah, it is not O of N, it's O of 1. That's why I say it's a little confusing, it's a little tricky one. What about this one?
That O of N also.
O of N? Are you sure?
Not sure, but that's my guess.
Why do you think so?
Because it'll be a specific number, and then it just has to run through it once and add that number to each one. No?
So it's gonna grow with the outer loop, right? It could be anything. R could be 10, it could be a million. And then the inner for loop is dependent on the length of R, right?
You're right. Okay. So it's squared. O(n) squared.
O N squared. Yep. I think there's a different expression for this because of how elim grows, but small answer, more like O of N squared. Definitely not O of N, but it's gonna be O of N squared at a minimum because it's growing with array. So array can be a million, therefore impacting what elim's gonna be. This can grow even higher. So when we do the inner for loop for num and elim, elim is going to be dependent on array. So O of n squared. Good job, guys. I think you guys are starting to get the hang of time complexity. Now, space complexity. So far, we have discussed on time complexity, but how we analyze the runtime of an algorithm as the size of the input increases. We can also use big O notation to analyze the space complexity of an algorithm or how much additional memory the algorithm uses when it's executed. The question, what is time and space complexity of your solution, is actually asking for two big O values, one for time and one for space. All right, so there are two different ones. They're not going to be the same. Space complexity example deals with how many variables / elements you are storing or keeping track of. Look at the function below. What do you think it is?
Is it O of 1?
No.
O of n?
Yes. Why do you think so?
Because it depends on how num grows.
Correct. Right. It could depend on how num grows, therefore changing the value of total. Right. So each iteration, total is being increased by 1. So it's performing an addition and an assignment, both which are constant time operations of O1. Actually, the assignment of assigning total is O1. But what makes it O of n is the fact that num expands. Right? Num could be 10, it could be 100, it could be 1,000,000, therefore increasing the space complexity of this. Right? So assignment of total is going to be O of 1 time complexity, but the space complexity will be O of n because of num specifically. Does that make sense?
Yeah, it does.
Space complexity is a little tricky because of this. So you'll probably have an easier time with time. What about this one? What is the space complexity of the following function?
Would that be O of n?
Why?
Because every time num grows, that array grows. So it's linear.
Yeah, so we initialize new list, right? It's an empty list. And then for each element in the array, we create a new value that's doubled and we store it within new list. Right. So if array has n amount of items within it, right? It can be once again 10 or 1,000,000. The new list will also have an amount of elements because the new value is being dependent for each element and what the array argument is even passing. So it's gonna be O of n. All right, it's gonna increase with what array might be. What about this one?
Would that be O of 1 because nothing's getting stored?
Correct, right? So the for loop, it's gonna iterate from 1 to whatever num might be, is gonna print each value, right? But the space complexity doesn't change because the amount of additional memory that we're using does not change. We have no additional variable being assigned here. The only variable in here is whatever n is, and it only holds a single integer at any given time. So it's gonna depend on whatever num is, but nothing else is being created, right? We're not assigning anything else. We're not appending it to no list. So it's gonna be O of 1. Someone else besides you. What is the space complexity for the following function? Kim,
I'm gonna guess O of N.
why?
Mm. Because they're only printing one number, even though they're looping through the whole thing. Is
Yep.
that right?
There's nothing being created here. I'm sorry, you said O of N or O of 1?
I said O of N, but I should have said O of 1.
O of 1. Yeah. O of 1, nothing else is being saved here. We're just printing out N. Yes, it's gonna depend. The time complexity will be dependent on num and whatever 10 is. But even then, like regardless, it's still gonna be O of 1. No other variable. We're not taking up any more storage. We're just printing out whatever N is. Right? Space complexity tips. Remember broad trends. What happens to a number of variables / elements being stored or tracked as the input gets really big? That's the biggest thing. When you look at this, right? What is happening to the number of variables or elements, right? Being stored or tracked as the input gets really big. Is anything being stored here? Are we keeping track of any kind of actual input that might take up memory? When thinking about space complexity, none of that's happening, right? Most primitives, Booleans, numbers, undefined, null, are constant space. If a number is 1,000,000 or if it's 1, it's still gonna be constant space, right? That's when we're talking about saving them into a variable. Strings require old and space, where n is the string length. Did you know that when you create a string, not the entire string, not every single part of that string is saved in the same area? Right? Only certain parts of your string are stored in in one space, but the way it's divided in your memory is actually kind of everywhere. You just aren't aware of it. Strings require O of N for space, depending on the string length, right? So the longer the string, the more space it's gonna take because of how it's stored. Not too important to know how it works behind the scenes. Just know that your entire string, if you have the word pterodactyl, probably the first 3 or 4 letters might be in one spot. The next couple ones are going to be in a different spot in memory. So it's going to require O of N space where the N is the string length, right? Reference types are generally O of N, where N is the length for arrays or the number of keys, right? For objects. So trying to loop through your loops or trying to loop through the dot keys method, O of N. Once again, the exact same picture we saw earlier. Logarithms explained. Right, so we have discussed some common complexities like O of 1, O of N, and O of N squared. Sometimes big O expressions involve more complex mathematical expressions like O log of N or O of N log of N. So what is a log or logarithm? It's the opposite of an exponent, right? Here is an example. I hate talking about log events because I'm horrible at explaining it. Log of 2, which are log base 2 of 8, it's gonna be the exact same of this. It's just written differently. The best way I like to talk about log of n is going to be by using the divide and conquer method, which we'll get into a bit, right? Essentially, how many times does 2 fit into 8? It's gonna be 3 times, right? So 2 to the power of 2 is gonna be 4, to the power of 2 is gonna be 8. So 2 to the third power is 8. And that's gonna be the exact same of log 2 of 8. I'm horrible at this. I'm so sorry. I will show you guys right now in pictures. It will make it so much easier. There is a lot of log bases, not just base 2, but for our purposes, we will treat all logs the same. Remember, we just care about the big picture. A rough rule of thumb, the logarithm of a number measures the number of times you can divide that number by 2 before you get a value that is less than or equal to 1. Won't always divide cleanly if y. So example, once again, using the exact same we saw earlier here, the number 8, the first iteration, when you divide it in 2, you get 4. Then you get that 4 divided into again, gives you 2. That's your second iteration. You get 2 divided by 2, you get 1. That's your third iteration. So the log of 8 is also equivalent to 3. Why are logs important? Certain searching algorithms have logarithmic time complexity. We'll get to those algorithms later in the course. Let me see if I can show you a picture of it. Excalibur. New file. Where is the new file? This is from our last class. Okay. I like to explain it in. Oh, no. Background in squares. And then let's say, how can we do this? We are looking for a number. And we're going to break this apart ahead of time so we can see how it works. All right. 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm sorry, it's gonna take a little bit. 10, 11, 12, 13, 14, 15, and 16. Some of the arguments you're gonna use, you're gonna try to find some kind of answer or some kind of variable, some kind of number, whatever, within a large set of data. And we're gonna just use numbers to explain. The way that log of n works is you're gonna get it might be a list, might be a dictionary, might be a range of numbers. The way that log of n works is that it uses the divide and conquer method. Let's say we're looking for the number 11. Well, the easiest way to doing that is to cut this in half, right? So you essentially create 2 halves. We're gonna cut it down the middle right here, right? And then we're going to work with both sides, right? Essentially, we're gonna see the start point and the end point for both of these halves. Start points right here, end points right here. We're looking for the number 11. We get a start point for the first half. Is number 11, what you call it, is it greater or less than 8? Right, we look at the end point. Well, number 11 is greater than the end of our first half. That means that it can no longer be part of anything past here, right? That was the first iteration we did. We cut half of the amount of iterations we wanted to do by just checking the endpoint of whatever this was. Right, we're looking for number 11, and we saw what was the endpoint of this half. We saw that the greatest number within the side was 8. 11 was greater than 8, so we know that everything else that comes before 8 is absolutely useless. We know that our number we're looking for is no longer here. So now we're left with 1 half. Right, well, we get the half that we have left over, and we cut this bad boy in half as well. We get a new start point and new end point for both these halves. This one has a start point of 9 and an end point of 14. This one has a start point of 11 and a start point of 16. Now we check 1 half. Is 11? Oh, I did this wrong. I'm sorry. We're gonna cut it in half right here. I did it absolutely wrong for this demo. The start point of this half is 9, and the end point of this half is 12. The start point for the second half is 13, and the end point is 16. Right? We no longer have any access to this. We already cut it out. We've already identified that this part right here is absolutely useless. The only thing that we need left over is to check these 2 halves right here. We check 1 half. Is 11 less than or greater than 13? Well, I know that 11 is less than 13, so anything that comes after 13 is absolutely useless. So we cut all this out. That was our second iteration. Now we have this one part right here. We're gonna cut to the half again, right? And we get new start and end points. This is the end point for this half, and this is the start point for this half, right? And same thing for this one here. We create a new start point and a new end point. Let's check the other one, the one on the left side. Is 11 greater or less than 10? Well, we know it's greater, so I know everything from 10 and before is no longer needed. That was our third operation, guys. Now we come to the last part here where we have 2 numbers. We cut in half, and all we have to do is check between one of these numbers. Is 11 greater or less than 12? I know it's not 12, it's less than 12, so I can cut this out, and I'm left with only 1 number left. That was our fourth operation. We're able to come to the number 11, worst case scenario, with 4 operations. Where initially we had 16 numbers, right? If this was done with a nested with a 1 for loop, this will be O of n, because n being 16 operations. We have to check every single one from start to finish. Worst case scenario, the number we were looking for would have been at the very end. So this would have been O of n, where n is going to be 16 operations. But because we use this divide and conquer method, this became O log of n, right? Where n ended up being essentially 4 operations, because that's how long it took for us to find it. Does that make sense? That's how log of n works. It checks how it can divide by 2. It divides things in 2s, and then it compares it and contrasts both of them. That's how you use it in your code. Understand? Yes, no? Did I confuse you even more?
Yeah, that made sense.
Okay, awesome. I hate log of n because I suck at explaining it, especially when I'm looking at this right here. How does this even work? And then I look at this like, what? Essentially, these operations, I just show you a visual representation of how that works. It cuts in half until it reaches the number that it's looking for. Here we saw it was 4, right? And then honestly, think about if we change this to 16, right? 16 divided by 2 is 8. That's 1 operation. 8 divided by 2 is 4. That's 2 operations. 4 divided by 2 is 2. That's 3 operations. 2 divided by 2 is 1. 4 operations, O log of n. Once again, we came to the same conclusion. We did the exact same thing here, but visually, right? That's how O log of n works when it comes to big O notation. I'm gonna stop it here, guys, because it is 8:53, and I want to leave this room open for any kind of questions. O of n always has been. Yeah, so if you guys have any questions, guys, this is your time to ask. I'm gonna go ahead and stop the recording. That way you guys kind of